I am in the textbook for page 214 for the review, and I've just brought this scan into my notebook because I need to be able to refer to the graph. So if you turn in your textbook to page 214, we'll look at this review. It says to fill in the blanks with one of the terms below. Terms may be used more than once. A linear function is a function whose graph is a line. Features of a linear function that can be compared include blank, which measures the steepness of the line. That's going to be slope. And blank, which indicate where a line crosses the y-axis. That will be y-intercepts. Number 2, a function that can be written in the form y equals ax squared plus bx plus c, where a cannot be 0, is a quadratic function. Features of this type of function that can be compared include minimums, maximums, and intercepts. In a blank, the ratio of y to x is equal to a non-zero constant k. This is a proportional relationship. The graph is a line whose slope is k. That constant of proportionality is the same as slope. Read each problem and complete the tasks. The heights of 2 model rockets that were launched at the same time are described in the table and graph below. Use this information for 1 and 2. So let's just look before we go any further, before we leap. What is the maximum of rocket A? What is the maximum speed it reached before it started its descent? Well, that was at 41. Gravity began acting as soon as the rocket was launched, and at 1 second into the launch, it was at 41 feet. For B, rocket B, that maximum occurred right here, and that's about, let me draw a tangent on there and we'll see what that is. It's between 12 and 16, and these are scaled in 2s. So that's at 14 feet. And that happened at 0.75 seconds. Yeah. Again, draw the lines as you need them. It really was a little bit more than 0.75, maybe 0.8 or 0.85, somewhere in there. I'm just going to say 8 for ease. I'm not going to round it to several places. All right, number 1. Jonas says that he cannot determine which rocket reached the ground first because the table does not contain any information about the time rocket A reached the ground. Is Jonas correct? Why or why not? Well, I can tell you easily when rocket B hit the ground, because right here it is. Rocket B hit the ground just before 2 seconds. But when you go over here to look for rocket A, it doesn't tell me that. It tells me that it was 25 feet on a platform when it was launched, but it doesn't tell me when Y is 0. In other words, there's nothing here that fits this pattern. We don't know what the number of seconds were. So I agree with Jonas. It does tell us that the rocket was still in the air, at 5 seconds, but that's all it tells us. It doesn't tell, or at 2.5 seconds, it was still in the air. It was getting close to the ground right here. I could guess that it happened at 3 seconds, or maybe 3.5, but I don't know that for sure. So I can tell you that B got to the ground first, because at 2.5 seconds, A was still in the air, but B was at the ground before 2. But I can't tell you precisely when it happened. So I'm going to go with that Jonas is correct. And the reason that I would say that is because there is no y-intercept. Excuse me, there is no x-intercept on the table. If they had just told me when y is 0, then we would know when x, that would be ground level when y is 0. Which statement is correct? Rocket A was launched from 25 feet above the ground and Rocket B from the ground. Well, if this is true, Rocket A would have a point 0.25, and Rocket B would have a point 0.00. So let's look up there and see. Rocket A has the 0.25 and Rocket B has the 0.00. So I think that's the answer. But let me look at all of them. Both rockets were launched from the ground. That is a false statement, because when seconds were 0, Rocket A was 25 feet high. So it was on a platform. Rocket A was launched 5 feet above the ground. That's not true. It was 25 feet above the ground. So I don't even have to read the rest of that. Both were launched for 25 feet above the ground. That is a false statement, because B has the point 0.00. So A is the correct answer on this one. Number 3. A car is traveling at a rate of 60 miles per hour. A truck is traveling as shown in the graph. Which statement is correct? Well, the car is at 60 miles per hour, and the truck is about, each of those is 20. It's about 50 miles an hour, I'm guesstimating, because at 51, we do have a point. This is 60. Maybe 48, 1, something like that. After 4 hours, the car will have traveled twice as far as the truck. Well, the car will have gone 120. That should be greater than the truck. The truck will have gone about 100, I'm going to guess. It is greater, but it's not nearly far enough. It would need to be 200 is greater than 100. So this is not the answer I'm looking for. In B, we have the truck's rate of speed is less than half the car's rate of speed. That's not true. The truck is about 50, the car is about 60, and that is less, but it's not half. It would have to be less than 30 for that to be true. So that is not a true statement. It will take the truck 4 hours to travel the same distance that the car travels in 3 hours. Well, 4 hours for the truck at 50 miles an hour is about 200. Now remember, I estimated that. The car is 3 times 60, That would be an exact 180. This one's a possibility because I did the rounding. So let's look at D. The car's rate of speed is 3/4 the truck's rate of speed. No, because the car's going faster than the truck. The car is 60. The truck is about 50. And D is saying that the car's going slower. So C is the only possible answer it could be. So I have rounded incorrectly. Let's look here. Let me zoom in and maybe I can. This line is 60 right there. This line is 40. And the point is closer to 40. I believe I have rounded wrong. Let's make this about 48 in 1. Because the point is actually right here and it is a little closer to 40. So somewhere 45 even might be a better option. But any way you stack it, the answer should be C. All right, number 4. A work day is 8 hours. If you hear that alarm in the background, I'm sorry. It should stop on its own. A work day is 8 hours. Sandra's total pay, P, when she works H hours, is described by the equation P, her pay, is 21.5 per hour. Boris's pay is described in the table. Who earns more money per day and how much more? So this is Sandra's equation. We need to write an equation for Boris. And so we're going to say Boris's pay equals some amount. Now they tell me that this is proportional because of the 0-0 rule. No hours worked, no money earned. But then they jump to 2. Now it would have been very nice if they had put a 1 right in there. So let's figure out our unit rate. If I take the total pay of $45 an hour, or $45 for 2 hours, so pay divided by hours is 45 divided by 2. I can divide that to get the hourly rate. So 45 divided by 2 is going to be more, but we need to know how much more. So $22.25 for 1 hour. That's Boris's hourly rate. So we can say that he makes $22.25 per hour. And they're asking us how much, who earns more per day. So for Sandra, you could do it a couple of ways. I'm going to go ahead and calculate the whole day. So 22.5 times 8. They told us the 8-hour workday is 172. And then Boris for the same 8 hours. It's not going to be a lot more because the numbers are pretty close for the slopes. But it will be a little more. 178. Is that right? Yes. So you subtract to find the difference. 178 minus 172 is a difference of $6. So let me check these just to be sure I haven't done something weird, because y'all know I can do that. All right, page 214 in the textbook. Number 1 is slope y-intercepts. Number 2 is quadratic function, not functions, excuse me. Number 3 is proportional relationship and slope. Number 1, Jonas is correct that the table does not tell. Number 2 is A. Number 3 is C. And number 4 is $8. Whoa. Ruh-roh. I have a mistake. Or they do. It says Boris earns $8 more per day. And I said he earns $6. So let's take a look. A work day is 8 hours. Sandra's pay is P equals 21.5H. Boris's pay is described in the table. Who earns more money per day and how much more? All right, so let's do 45 divided by 2. There's the problem. Miss Amanda can't use a calculator. One thing I would encourage you to do is to use your pencil to type in on the calculator. That's not my problem here because I just had the wrong answer. There's no excuse. But that is a good tip, is to use your pencil. So let's change Boris's equation to be 2250. And 2250 times 8. I shorted him $2. That is 180, which means this is 180, which means this is a difference of $8 more, and that goes to Boris. It is a good thing I check my answers. But that page is good to go.